Hello class, my name is Alejandro Garcia, my partner is Christina Hulter, and we will be presenting our final project on a humidity converter. So the inspiration from our story came from our food insecurity assignment, and we kind of just built on that assignment. And we also got the idea from redwood trees and how they've been able to survive in the Bay Area by feeding on the Bay Area fog. We wanted our idea to be simplistic, realistic, and practical, and something that we can use our basic engineering knowledge from this class. So our purpose is to provide affordable drinking water for consumption in a simple and cost-effective way. Wanted to help people to be prepared for emergencies so that they don't have to become dependent on governmental entities, and just spark the idea that there is another way of getting reliable water supply. So this is what the final design for the FogNet looks like. It does consist of little cylinders here that you can see where the water droplets would come down and filter their way to the bottom, where they will be distributed through a water piping system. Originally, this is what my original FogNet idea looked like, and it is a little different. I figured that by eliminating the sharp points, it would help. It would reduce the friction, which would allow the water droplets to run smoothly through the entire FogNet and provide a quicker access to water. So initial research. So we learned that that 1 cubic liter of fog contains 0.5 through 0.5 grams of water. You could catch up to 10,000 liters of water, and that would equate to 200 to 600 liters per day. This type of system is ideal for arid, coastal, and even desert climates. We would use a gravitational piping system for the flow of water and the distribution of water through the piping systems. This could be a very low cost product. You can get into build your own product for anywhere from 100 to 200 for all the materials. And critical factors for getting good water output include the density of fog, wind speed, and the material of the mesh. And we learned that there are some third world countries that are currently using this method, such as Chile, Morocco, and other third world countries in Africa and South America. Splitting the work. FogNet was my responsibility, and pipeline distribution was entirely by Christina. Since we decided to split up the work based on our interests, Christina is more focused on civil engineering, whereas my interest is more on the mechanical aspect. So that's why I decided to focus on the FogNet. So the design functionality. The FogNet's original design consisted of hexagonal shapes. After consideration, I realized that the points on the hexagon might cause the water vapors to get stuck, and we might lose water through friction, and just might take longer through the water to go through the entire mesh and filter through to the pipes. So we eliminated that design and decided to use this system here, where they would filter down through these cylinder objects, and here is a an insert hole where we can run our piping systems, where the water would be able to be connected here through maybe some sort of 90 to catch all the water and then filter it down to where it needs to go. Why should someone buy our product? I think this is a product that people could benefit from. It's very easy to learn how to use this product. I think that our product would be better than someone that other products that are on the market, because our product would be accessible to anyone. And I think our target customers would be military personnel, homeowners, and farmers. Um, I think that our simple design would make this more user friendly. And this is our very first phase of production. So, we're open to make improvements based on how our understanding of this product evolves. And here is the final design of what the FogNet design looks like. Different angles here that we have from Onshape. And then here is a design of the post for the FogNet. I made these holes on the post. I figured that we would want to maybe tie down some of these materials onto the post that would be driven into the ground and placed over concrete so that way they have good stability. Thank you.
Hi, I am Chrissy Hulter, and I am here to talk about the water distribution system for the humidity converter. In order to distribute the water that has been harvested from the air, we need to set up an irrigation plan for how to efficiently push the water out to every plant evenly. And in order to save water, the best irrigation system we found would be a drip irrigation system. This is also known as a trickle irrigation, and it is the most cost efficient and sustainable, as well as being the most helpful for plant growth, as it is able to reach the roots of the plants much faster and easier. This can help promote healthy growth. It minimizes waste of water, as well as directing the water right to the roots of the plants. The biggest element of a drip system is that the water drips slowly so as not to overwater. It can also be placed both above the soil as well as buried beneath the surface, which gives a lot of options for layout, especially in such a large space. Overall, this is the most efficient and conservative way to ensure consistent water for the plants. We decided to go with flexible hoses as it is the easiest to install. It gives a lot of flexibility around corners, and it's also able to be buried underneath the surface. It's safe to be underneath pads, which is what I decided in a lot of my design, is that it would be best to go underneath some pads. This makes just the whole design process and install process a lot easier. The type of hose that I thought we should use is a soaker hose. These hoses are just full of a whole bunch of holes that water flows through slowly and very evenly. They allow for a very slow drip system, and it requires far less water than any sprinkler systems, and they give a really nice, slow, steady water stream that allows for even watering. There's also no need for any slope, and they work going uphill, so placing these around any obstacles is perfectly fine, and they work great. This type of system would work up to 200 feet in any straight direction. This means that this system would allow up to 200 feet of water flow, and with a maximum length of hose being only 82 feet in our garden, This ensures that with a good pump, this system will be working at maximum efficiency. Here's my original design for the irrigation system of the humidity harvester. My original sketch of the full layout, as well as where the piping and the hoses would go and which boxes would need what. Here's my final design, which is able to show the shed, which I ended up moving the humidity converter to be on the back side, so it has a good path to get to do maintenance and such. This is the pump, the water pump, that pumps all the water out through these pipes. So it's able to go through into the greenhouse on the outside to each box individually, as well as being able to run down the center of each box to give even flow to every plant individually. With this plan, it is a much more even spread as well as a lot less hoses than my original design. This design also allows for a water reservoir to be stored in the shed so that any excess water from the humidity converter is able to be stored for both abundant water flow, in which there might be too much water coming in and it needs to be stored somewhere and it can't go out to the plants fast enough, or for the possibility of a drought so that the plants are still able to be watered even if there's no rain or humidity in the air. Thank you so much for listening and watching this presentation on our humidity converter for the FSUG for Ohlone College.